Comparison of AC and DC transmission. The merits of two modes of transmission should be compared based on the following factors: economics of transmission, technical performance, and reliability. Economics of power transmission. In a DC transmission, inductance and capacitance of the line has no effect on the power transfer capability of the line and the line drop. Also, there is no leakage or charging current of the line under steady state condition. A DC line requires only two conductors. The AC line requires three conductors in three-phase AC system. The cost of the terminal equipment is more in DC lines than an AC line. Technical performance. Due to its fast controllability, a DC transmission has full control over transmitted power and ability to enhance transient and dynamic stability. It is associated in AC networks and can limit fault currents in the DC lines. Stability limit. The power transfer in an AC line is depend on the angle difference between voltage phases at the two line ends. For the given power transfer level, the angle increases with the distance. The maximum power transfer is limited by the consideration of steady state and transient stability. The power carrying capability of a AC line is inversely proportional to the transmission distance, whereas power carrying ability of DC line is unaffected by the distance of transmission. And next one is voltage control. Voltage control in AC line is complicated by line charging and voltage drops. The voltage profile in an AC line is relatively flat only for a fixed level of power transfer corresponding to surge impedance loading. The voltage profile varies with the line loading. For constant voltage at the line ends, the midpoint voltage is reduced for line loadings higher than surge impedance loading. The maintenance of constant voltage at the two ends requires reactive power control. The reactive power requirement increases with the line length, although DC converter station require reactive power related to the power transmitted. The steady state charging current in AC cables pose serious problem and make the break even distance for cable transmission around 50 kilometers. The next one is the problem of AC interconnection. The interconnection of two power systems through AC ties requires the automatic generation controllers of both systems to be coordinated using tie line power and frequency signal. The presence of large power oscillation led to the frequent tripping, increase in fault level, transmission of disturbances from one system to other. The fast controllability of power flow in DC line eliminate all the above problems. The asynchronous interconnection of two power systems can only be achieved with the use of DC links. Disadvantages of DC transmission: high cost of conversion equipments, inability to use transformers to alter voltage levels, generation of harmonics, requirement of reactive power control, and complexity of controls. Reliability. The reliability of a DC transmission system is good and comparable that of AC system. The reliability of a DC link has also been very good. There are two measures of overall system reliability: energy availability and transient reliability. Energy availability equal to 100 of 1 minus equivalent outage time, where equivalent outage time is the product of actual outage time and the fraction of system capacity lost due to outage. Thank you.